Hello and welcome back to another episode of Math with So. And today we're going to be rewriting rational exponents. A rational exponent is just a fractioned exponent. So this x to the 2/3 is considered a rational exponent. And it can be rewritten as a radical. And that would be a cube root of x squared. So the number that's on the bottom of the fraction goes on the outside. And the number on the top goes on the inside. However, you could also write it as the cube root of x and then square everything, which has some value later on. Okay? And this can go in either direction. So you could be given an x to the 2/3 and be asked to write the radical. Or you could be given a radical. Let's say we had the 5th root of y to the 7th power and be asked to write it as a fractioned exponent or a rational exponent. So this would be y to the 7/5 because you'd have to put this 5 on the bottom and the 7 on the top. Okay? Now there's a lot of inherent benefits to doing this because if you were given something like the cube root of x to the 3rd, well, let's not do the cube root of x to the 3rd. That's ridiculous. The cube root of x squared and had to multiply by the 4th root of x to the 5th, you can't really do that in its radical form, but you could do it in its exponent form. This would be x to the 2/3, and this would be x to the 5/4. And then here, when you have a problem where it's an exponent and then you got to multiply with another exponent, you're not actually going to multiply the exponents. You would have to add them. This is going to be x to the whatever the 2/3 plus 5/4 is. And you can either use a calculator for that, or you could understand that 2/3 added with 5/4, you would have to multiply this one by 3/3 and multiply this one by 4/4 to get that least common denominator, and you'd get 8/12. And you'd get 15/12. And if you add 8 and 15, you would end up with 23 over 12. So this is x to the 23/12, which I miswrote. Here we go. X to the 23/12. X to 23/12. So that is something that would be very, very difficult to do in its radical form, but as an exponent, it wasn't that bad, okay? So let's do another one. Let's do something that's a little more exotic. Let's say we had 8 x to the 4th power over y to the 1/2 power, and let's do the cube root of this. This is ugly, right? You can do this in all its raw forms. So you could start this out by just doing the cube root of 8, which is 2, and then recognizing this is a cube root of x to the 4th, and this is a cube root of y to the 1/2. So from here, you have options. You have options to keep this as a square root or cube root. But if the number on the inside is bigger than the number on the outside, it could be simplified a little bit, and it does a little bit. This would be 2x to the 1st, and then the cube root of x, because 3 goes into 4 one time with 1 left over. And then here we would have the cube root of y to the 1/2 power, which you really can't, 3 doesn't really go into 1/2, but you could rewrite this as y to the 1/2 power raised to the 1/3 power, because this is kind of like raised to the 1st power. So you could recognize that 1/3. And then what do we do here when we have 1/2 raised to the 1/3 power? That would end up being multiply to get 1/6. And then we'd have 2x to the 1st cube root of x to the 1st. Now, this problem has turned everything into a radical and a fractioned exponent. It depends on what you're asked to do, but this was more of a simplifying problem, and we would technically still not be done because a long time ago you learned that you could not keep a fractioned exponent, or a radical more importantly, on the bottom of a fraction. So we should continue on our journey and continue to solve and get rid of this fractioned exponent on the bottom. That, however, my ladies and gentlemen, is a different video entirely. So for today's purposes, we are going to stop there, but I am going to solve this exact problem in another video where if you have a fractioned exponent on the bottom of a fraction, that you would need to do something to get rid of it. Until then, I will see y'all in the next one.